So I will take over, and I hope you soon will see my screen here. And again, welcome very much to this webinar, where the title is The Mega Trend of Electrification and How That is Driving Heat Pumps and Brazed Plate Heat Exchangers. We are, so now I get everything ready. So my name is Anton Olausson. I will take you through this webinar today. I'm the segment manager of residential heating at SWEP. And in the SWEP world, that is heat pumps and boilers is including in that residential heating. I've been part of the company for some time. I started back in 2005 and been working within sales and marketing ever since, with global accounts as a sales director and some business development positions. And I've also been outside to refresh myself a little bit for a couple of years and came back in 2018. And now I'm responsible for the segment manager for residential heating. So if we look at the agenda, there it switched. We will start. It's a big crowd here, and there might be so that some of you don't know SWEP that well. So I will start with a short summary of SWEP as a company, and then go over to a little bit of what observations we can see that is driving this global electrification that is ongoing right now. I will go more deeper into the EMEA heat pumps and the market drivers that is here on this market. The refrigerant trend that has been a topic discussed for many years now, but as what we see as the status of today, where we are, and how that affects SWEP and the way we develop our brazed plate heat exchangers. Then we will also go into our technology roadmaps and what ongoing developments we have right now. And lastly, a short introduction to a new technology we introduced in 2019, which is Silix. And we finalize with some questions and answers at the end of the presentation. So here we have SWEP. SWEP is a company that is dedicated to brazed plate heat exchangers. So everything we do while we're awake, we're focused on doing the best and develop the best products and offers for the brazed plate heat exchangers. And today we are a little bit above 1,100 employees on a global basis. We have sales in over 90 countries, where we cover over 30 countries of that with our own sales force. And with the rest we do through our distributor network to cover those needs. We have 5 plants in all the main continents here. So one is in Tulsa, US. We have our headquarters and the factory in Landskrona, Sweden, and another factory in Europe in Kosice, Slovakia. And then in Asia, we're also covered with 2 factories, one in Kuala Lumpur, Malaysia, and one in Suzhou in China. And the yellow dots you see on this map are the warehouses that we're utilizing to cover, and they are in 8 different countries. And more than that, we're also having R&D developments. It's mainly in Europe and in Asia. And in Asia, we have it in China, and also a satellite in India that is supporting to do all the developments we need within our brazed plate heat exchangers. We are owned by an American company, Dover, already back since 1994. Our company started when the brazed plate technology was born. We started in 1983 outside Landskrona in Sweden, and have had this American owner, Dover, that has around 30 to 40 companies like SWEP, and they have supported us well during these years since '94. Okay, so let's talk a bit about the global electrification trend, or basically a fact that we see going on right now that is driving the electrification and the renewable and the energy efficiency. And if we start to look within EU and Europe, EU has earmarked over 500 billion euros within their Green Deal and the recovery package. If you look into those packages, that is the sum you will get together that is dedicated for the goal to reach net zero emissions. And one important part of that is how you direct the investment money. So the European Investment Bank are directing 2 billion euros per year towards the renewable the coming years onwards here. One example within this is the Boris Johnson and the UK 10-point plan that they call the Green Industrial Revolution. That part of, I think it's on the point 7 in that plan. They have a goal to reach 600,000 heat pumps by 2028. That is, of course, a very aggressive goal, but it's still, even though they don't reach all that, it's still a massive direction towards focusing on heat pumps and developing that. Because in that country as well, as you know, it's a lot of other gas-driven heating, so they need to do that change if they want to reach the net zero emission goal. We have within Europe some ban on gas in some countries in new buildings that has been primarily stated by the Netherlands and the UK. There are still heating with oil boilers, and there are more and more countries gathering up to ban those oil boilers. And the examples are UK, France, Germany, Netherlands, and a few more. If we jump over to the Americas to see their drive, I think this with electrification has been very present in Europe for some years. But we see it more and more on a global basis, also in the Americas and in APAC. And in Americas now with the new Biden has done a lot of executive orders to join the Kigali amendments. He has put an infrastructure plan of $2 trillion, part of the American Jobs Act, that will support green initiatives. It still need to be vetted in the Congress. It's an executive order and a plan that they need to push through the Congress. Part of that is also a goal to decarbonize electricity by 2035. And those type of goals has not been previously, before Biden, it has not been that direction. So we're very happy and welcome that America is also taking part of that journey. So you need to be tiptoed. So there are no indications of ban on any gas or oil fracking for that sake within Americas. There are certain states that takes those decisions. California is one of them, but on a governmental level, they have to balance the needs and the opinion within the whole country. If we go over to Asia, and in China, that has very recently approved the next 5-year plan that was in March this year, and they call it the green or the energy revolution. That is a lot of focus on the electricity and the natural gas and the energy efficiency. That are big parts of this new 5-year plan. And the focus is also on the urbanization that has been going on for decades, but it's still an important part of the 5-year plans, and that is driving the need for electrification and comfort. We have, as many of you know about, the coal to electric that was booming a couple of years ago in 2017, 18, 19. That is still continuing, but a bit in a slower pace. And we also see in the Pearl Delta region, for example, there is also a good drive with the heat pumps / mini chillers and that is more driven not on incentives but more on a commercial basis. If we look on a few things that IEA, International Energy Agency, have released recently, they highlight that the energy efficiency has to be seen as the first fuel to manage the global energy system going forward. So all other measures that we are focusing on doing, it's still very, very important to focus on the energy efficiency. And I think recently, just a month or so ago, they came with another report where they are pushing that we should not use boilers after 2025 to be able to reach the carbon neutrality by 2050. Yes, if I move on. So if you look at the right side of this slide, just to see a little bit on the market development within Europe and EMEA, I often utilize the figures from European Heat Pump Association, and that has not, the figures hasn't come for 2020 yet actually. It takes time to collect them from all the different countries. That's the reason. So here you will see the 2019 figures. Very high growth on the air-to-water heat pumps, 37%. Ground source has for many years been quite stable. Exhaust air go up and down from year to year, still on a quite low levels. And if we look at the overall heat pump development, which was, if we include the air-to-air heating as well, that was 18% up. So if I should look at 2020 figures, from what I've seen when not all statistics is collected, but I think it will land around that figure, even though it was a pandemic during 2020, air-to-water heat pumps managed to increase with 13%, even though there were some lockdowns and in certain countries factories were closed down for some periods. And if you look at some country specifics, Germany was booming due to their new incentive plans. They grew with 40%. France had a smashing 2019, so 2020 it went down a little bit, also due to the incentive plans that will change a little bit. The super bonus in Italy boosted up 18%. But more exact figures will come later this year. Looking at policies and regulations driving refrigerants primarily, we have the Kigali Amendment and Montreal Protocol that is pushing this to get rid of the HFCs. And in Europe, we have the F-gas that has been in work since 2015 and pushing a lot this whole change. So the refrigerant, I have a separate slide, the next one I believe it is, where we will look into the specifics on the refrigerants and our view of that. Eco design here in Europe is driving the high seasonal or reward the seasonal efficiency, and also bringing in that if you have a refrigerant below 115 global warming potential, you get very big benefits of that when you do your ratings. And the low water pressure drop that has been increasing more and more the recent years, and also affects us when we develop our new brazed plate products. So was the presentation mode? Something is flipping. Tom or Helen, what do you see right now? Because my screen is flipping around.
Now we see the desktop or the editing mode of your presentation.
Yeah, all right. Just jumped out. I'll try to go back to presentation mode. Yes. Now you see it in presentation mode?
Yes.
Perfect.
Yes.
All right. And if I continue on the pricing, for example, that has been driving, it peaked in 2018, but it still has gone down, but still remains on a high level. That is also pushing and driving the refrigerant change. Other market trends, it's the energy performance and building directive that is pushing for better insulated dwellings. That will result in lower heat demand. Is needing, going back to the IEA and keeping that energy efficiency will be the first fuel. So this is happening a lot in Europe and in other parts of the world, that we need to improve that to have lower heating demand basically per square meter. So this is primarily in new buildings, driving lower capacities in the heat pumps and also focusing more on the comfort with the cooling. But we also know that we have a big stock in Europe where retrofit is needing, and that is driving the capacities up. So depending on what you believe in, you can see how that will balance. Low global warming and natural refrigerants I will speak about on the next slide. We have more and more reversible systems for cooling, raising the demands for a good distribution system and freezing robustness if we go into the SWEP world and our heat exchangers. And inverter-driven compressors to elevate focus on the part load. So, speaking more on a bit of a deep dive into the refrigerants. In the past, life was a little bit more easy. You only had one or maybe two refrigerants to deal with and to develop. Right now, we all know that that is different. And the main ones that we're looking at in Europe, here I have divided it in air-sourced and ground-sourced heat pumps with a focus on the European market and how our picture and how we see it. So air-sourced heat pumps, you have the famous R32 and propane, another few of 454B and 454C, and possibly 452B. I should admit that I don't know of anyone commercially releasing a product with 452B. It could be somewhere out there, but it's very small volumes in that case. Within air sourced, most of the developments has been going on now for 2018 to 2020. And up on the upper right-hand corner on the slide here, you see our view of the air-sourced heat pump market, where 50 to 60% today are using R32, and 35 to 40% is propane, and the rest are the other refrigerants, where maybe the bigger ones are 454C. So that's how it looks on the air-to-water heat pumps. There has recently, I think the discussion has been longer, but it has surfaced a little bit more recently on the HFOs. We know due to the global warming potential, or the higher global warming potential between 4 to 5, 6, 700, that they are not a long-term solution. The propane is the only long-term solution. But another discussion has occurred with the composition of some, for example, the 454C, that has a component of 1, 2, 3, 4 YF. That is part of the PFAS chemical that can be harmful to mammals. There are ongoing investigations and absolutely not any decisions yet. I think we're expecting a decision within 2 years in EU, but that has stirred some insecurity on the market, and companies usually don't like insecurity, so that is affecting companies what refrigerant they choose. If I go over to the ground sourced heat pumps, it looks roughly as on the air source, but it's here most of the developments are basically ongoing right now, and here most of the decisions are not taken. Some are going to R32, it seems like, some propane, and here the 454C should have a better possibility because it has a big glide, and it's much easier to handle in a ground source heat pump, and you can actually utilize that glide. Propane will be a little bit less used here because you're indoors inside. It can be solved with other safety measurements. So there are companies using or looking at having the propane. So all this is developments right now, and we will see in a while where that will land. All right, so what we in SWEP, when we develop products, what we focus on, because these new low global warming potential refrigerants and natural ones, they have different characteristics, and it makes it more difficult. I know it makes it more difficult for the heat pump manufacturers, but it also makes it more difficult for us on the component level to, if we want to optimize and making the perfect products. There are different characteristics. And how we have chosen to do it going forward, that we will more look into platforms where we can utilize, and in the same platform utilize several different plates to be able to fit and optimize for these different refrigerants. And if we have those possibilities, it gives a much better advantage. So that is the new ongoing developments that we will utilize going forward. And we also invented a new adaptable distribution to this, also due to new technology that's coming up, both from a technology perspective, but also in production, with new automation possibilities, and with the need, when we have so many different refrigerants, we need to be more adaptable on the distribution to have it optimized for each situation. We're also focusing on the low refrigerant charge, and we have worked a lot with our we'll work with the asymmetry and the press depth is needed to do to manage this, and especially with the mildly and highly flammable refrigerants that are utilized today. This with a low refrigerant charge has become more interest, but we also need to understand that it has to be balanced, especially if we speak about the air sourced heat pumps. We need to balance that against the air coil. So, and therefore we also have a broader platform that for each situation we have different heat exchangers to choose from. Also, the higher increased demand on the low water pressure drop, we have developed a new generation of asymmetry to manage this. I will in another slide speak a little bit more on that asymmetry. Focus with the possibility to mix different plates. We can manage different refrigerants, but also different specifications. If you want to have a tight temperature approach or a medium, or what levels of demand you have on the water pressure drop, that we can manage with mixing, having this platform and mixing the plates. We have safety solutions as well now with specifically propane, I would say. And we are developing a new double wall with a new technology. I have a separate slide on that, so we speak more. And reversibility, not only for the defrosting mode, but also for the increased demand on comfort, with also include cooling in the heat pumps. That we need to look into and tweak our heat exchangers in a little bit different way. All right, so the technology map, SWEP heat pump technology map, that has been ongoing for some time, and that will be also released a little bit in the future. If I again go back to the new generation of asymmetry, we have for some time developed new asymmetries to meet the new demands of the refrigerants, but also the lower water pressure drop that I would say primarily started actually some time ago in Asia and China, and has become a stronger demand also in Europe here. So we have for some years done this development. If we speak about asymmetry, SWEP was the first company releasing in 2008 the first asymmetrical unit on the market, which was an E-unit. And that has developed, and then in a couple of years later it was also released in what we call a medium-sized range of heat exchangers that are the ones that are utilized in the heat pump market. It was also the first unit with asymmetry in that size of products. And we have developed this year over year, but now we see another step change that we were needed due to these changed demands on the refrigerants and also the lower water pressure drop, to be able to manage the same heat transfer but still lowering the water pressure drop. The new products we're coming out with now are included this next step change within the asymmetry. Going to the next one, we have what we call Celix, which is silicon oxide nanothin layer that we cover the heat exchanger with, also inside the heat exchanger, to manage a better corrosion resistance, as well as scaling and fouling and metal leaching. That has also been developed for some years and was released in 2019, already available on the market. As I've briefly mentioned previously, we have a new distribution system to manage, to optimize with these new refrigerants, and having a good cost and production efficiency in production. And we have been the recent year focusing a lot on the automation in our production, and that has given us new possibilities and within our development to optimize a distribution system. The next one, it's Hypertwain. That is a new groundbreaking technology where we integrate a suction gas heat exchanger into the normal heat exchanger, basically to boost in two-phase applications, to boost the heat transfer coefficient, and you get the most of their advantages when you are doing reversibility modes and focusing on the seasonal efficiency, where many of the COP ratings are focusing more and more on, and you will improve the freezing resistance. And this technology basically, instead, if you have a normal heat exchanger, you need often to utilize 30% of your heat transfer area to manage the superheat. With this new technology where we integrate the suction gas heat exchanger into the heat exchanger, then you only need to utilize 5% of the surface to manage this superheat that you need. And the last two ones, it's the next generation heat pump condenser. It's aimed at new refrigerants and has a focus on the air-to-water heat pumps. I have another slide on that one, as well as our new double wall. Here, just to quickly give you an overview to set the frame going forward, this is the platform we have for heat pumps. Depending on what capacities and what specifications and needs you have, we have a smaller range with a 4 size and 8 size, and then the medium range with a Q20, our new developments. We have the double wall, mainly within heat pumps due to the propane requirements that some choose to use. And then for more commercial sized heat pumps, we have the bigger sizes of the 250 AS. So basically all these function very well with whatever refrigerant you choose to design with. And we have the managing the working pressures up to 49 bar, which is the highest requirement for the R32. So this is just to set the frame that we have a big portfolio to cover all the different type of needs that can be on the market. And another discussion is with the refrigerant charge, since we have the highly flammable and mildly flammable refrigerants, and everyone is designing differently. Maybe also depending on how you need to balance your air coil. So through that, there are needed to have different type of heat exchangers to cover all the different needs. Yes, So here is the next product that will come up at the end of this year, and where we have prototypes available. It's a new generation heat pump, condenser, and evaporator. Primarily focused for the air-to-water heat pump market that is very big in Europe, but it's also functioning well for our ground-sourced requirements. It will manage up to above 20 kilowatts. It has been dedicated for the low global warming potential refrigerants, and we have mainly focused on the R32 and propane, since that is the bulk of the market, but we have also made sure it has a good fit to the other refrigerants as well. And we managed to do all these different refrigerants since we have a platform where we have several different plates to mix for the specific need that you have. Tight to medium temperature approach and low water pressure drop, that's what we've been focusing on. We have implemented all our new technology that we have with the highest asymmetry in the range, in our heat pump range, with the new asymmetry level and that new technology and patented that we have done. We have also focused on the new distribution system to have a good evaporating duty, since there are more and more requirements on the defrost, but also managing the cooling requirements. So we have put extra focus on the distribution in this development. And as I mentioned earlier, we have worked on to have as lean production as possible and increasing the automation in our production cell. That has also created new possibilities for our how we develop our products. Partly, of course, that we can utilize several different plates in the same platform and envelope. Yes. And here, our new double wall that will be ready at the end of this year, prototypes available in Q3. We have 2 bigger sizes in double wall, so now we complement it in the smaller range with 318 millimeter high. It has the highest efficiency on the market, and it will be when it is released, it will be the first product that has or a first double wall which manage also to implement asymmetry in it, and that creates, especially for heat pump requirements, give a very good efficiency with low water pressure drop and very low refrigerant holdup volume. If you, for example, are looking for a double wall in a propane heat pump, it's a very tight channel with low refrigerant holdup volume. But just to set the scene, to give an understanding that those who choose to go for a double wall solution, in this specific case, it's roughly 20% lower efficiency versus if you would have used the same single wall unit. That is roughly what you lose in the heat transfer efficiency with our technology of double wall. Very cost optimized. It's also compared to other technologies or on the double wall, we only have leakage in one place, so you could have, if you want to utilize digitalization, you could potentially set the leak detector, a sensor, to manage to signal and warn if there is a leak, just as an example. And here it's just a little bit more information on Silix, which is our silicon dioxide in the nano range thin film technology, where we seal all the inner surfaces of a heat exchanger. And this technology has been on the market for quite some time, but no one has found a method to actually manage it within a closed unit as the heat exchanger is. I know it, for example, on air coils, it has been different type of coatings for quite some time, but there you have an open surface where you actually can coat. In a heat exchanger, you need to go inside, and that has been the difficulty to manage to have a coating layer into all the different small cavities. And this we managed to do through a special process that is ongoing, where we pump in this silicon dioxide in gas form into the heat exchanger and allow it to take hours actually, so it can go into all the small different cavities over the whole heat exchanger to get a good layer. And this we can, through advanced optical measurement techniques, we can also measure that all this, the heat exchanger everywhere is covered. And the main advantages with it is to have a more corrosive resistant heat exchanger. You can have other benefits of the scaling and fouling, because maybe in a non-scientific wording, it's very slippery surface. So you will decrease the tendency of scaling and fouling. In certain areas, maybe not specifically in an air source heat pump, but for a hot water heat pump, for example, metal leaching could be, there are discussions increasing more and more about the metal leaching from all different components into the drinking water. And we have cooperated with UBA, who is mainly driving this, and done a lot of measures, and we are decreasing the different metal leachings considerably from a normal heat exchanger. And since it's a nano-thin film, we do not affect the thermal or hydraulic performance. The effect is within the tolerances of our measuring equipment. So that will stick the same. So that was actually what I intended to go through. Maybe I took a few minutes more than what was planned. From our set time here, we have another 5 minutes for questions and answers, but I have more time. So for you who can stay more than till 10:45, I'm available here to have some discussions afterwards. Helene, are you